Hello everyone, this is Aditya and this is the lecture 3 of Special Theory of Relativity, and today we are going to discuss Lorentz transformation equations. So in lecture number 2 we had discussed about Michelson-Morley experiment and the second postulate of Special Theory of Relativity, that the speed of light is constant for all inertial frames of references. So if speed of light is constant for all inertial frames of references, speed of light in vacuum, when I say speed of light, I mean in vacuum. So if it is constant for all inertial frames of references, it means that Galilean transformation is not correct. It is correct for small velocities, but for high velocities it is not true, because it would imply that the speed of light when depends upon the observer who is observing the light. So it means that in that case light can be c plus v or c minus v, the speed of light, so which is not true. So we have to change the transformation equations from Galilean to Lorentz transformation. So today we are going to discuss this on. But for that, please do like, share, subscribe, and please support this video. Now let's start. And in that video I made a small mistake regarding Maxwell's equation. When I was writing Maxwell's equation, let me correct it. Okay. So in the video I had written, I guess, this is del operator, Nabla operator. So it is Nabla 2. Then there will be an E vector because it is applied. Nabla 2 is applied on E vector, right? And it is equal to 1 upon C square del 2E by del T square, right? And Nabla 2 applied on B vector is equal to 1 upon C square del 2B vector by del 2T square. Okay. Now what I had written in that video, I had written by mistake del 2 dot E, like this I had written, I guess. So because I was recording that video in night, so maybe I made that mistake and I did not checked also. But when I was watching the video again, then I observed that this was the mistake, right? So this is the operator where Nabla 2 is actually the dot product of Nabla, which means that since we know that Nabla is equivalent, we say it like this, is I vector del by del x plus j vector del by del y plus k vector, k cap actually, del by del z. Okay. Now when you take the dot product or Nabla square, basically, because Nabla square is then not a vector, right? Since dot product gives us a scalar magnitude vector, sorry, scalar magnitudes, right? So it means that when you take the dot product, you will get del 2 psi, sorry, del 2 by del x square, not psi. I was thinking about quantum mechanics, forget that, plus del 2 by del y square plus del 2 by del z square. Okay, so it is this operator, and when you apply it on this, this operator is applied on E vector, then what you will get? We apply an operator on a vector, right? If you don't know about operators, I've made a one shot on quantum mechanics. In that I've discussed about what are operators. You can watch that. Okay. So when you apply it on this, applied on E vector, so what you get? Basically it is Nabla 2 E vector. So when you apply it on it, you will get del 2 by del x square E vector plus del 2 E vector by del y square plus del 2 E vector by del z square. Okay. So this is the actual equation, and what I had written was, I had taken the dot product over here, which was wrong. So this is the actual expression which we will get. Okay, so there's a vector over here and this is also a vector. Okay, and similarly for this also. Okay, and of course E vector is actually a function of x, y, z and t, right? We know it. Okay, that is why we have a partial derivative everywhere. So now let me erase this, and same for B vector, it is also a function of x, y, z and t, right? We know it. So let me erase this. This was the small mistake which I needed to point out in this lecture. Now let's move to Lorentz transformations. Okay, so let me erase this. Now let's understand what is Lorentz transformation equations. So earlier in Gaussian transformation equations, we had x prime is equal to x minus vt, y prime is equal to y, z prime is equal to z, and t prime is equal to t. But in Lorentz transformation, we are going to assume that x prime is equal to ax plus bt, and y prime is equal to y because there is no motion along y direction currently, and z prime is equal to z, and t prime is equal to dx plus ft. Here dx is not the derivative term, it is d. Over here a, b, d and f, they are the constants, but these constants are not like numeric constants. They depend upon some factors which we will see in the later part of this video. Okay, so why I have assumed a linear relation for t prime and x prime? Because of the homogeneity of space and time. If I take a quadratic term or a cubic term or any other term, then it would imply there is an acceleration, and we don't need acceleration. Why? Because it is an inertial frame of reference. Okay, so that is why this is the relation. Now let me solve it. But how are we going to find these four constants? Let's see. So assume there is an event, or let's assume this your S frame, correct? And this is S dash frame. Of course, from lecture 1 you should be knowing that the x and x prime axis should coincide, right? Should be on same line, right? So this is origin for this, and this is the origin for this. Okay, so what are the coordinates of O prime with respect to S frame, S dash frame? It is 0, 0, 0 and sometime t prime, at some time t prime. Okay, and what is this? This is 0, 0, 0 t. For S frame, the coordinate of O is this. Now what is the coordinate of O prime with respect to S frame? It will be velocity into time 0, 0, t, right? Because with respect to this frame, O prime, that is S frame, has moved velocity, the velocity with respect to this frame, times the time in this frame which has elapsed, it is t. So this is vt and this is the coordinate. So O prime will be this according to S frame of reference. Okay, so let's substitute it. So what is x prime? X prime is of course 0. This is x prime, this is y prime, this is z prime, this is t prime, and this is x, this is y, this is z, and this is t, correct? So let's substitute the value. So 0 is equal to ax, what is x? X is equal to vt, right? So vt plus b into t plus bt, correct? Now of course t is the value of t is for all values of t, not just one value of t. So of course we can divide both sides by t. So we will have av plus b is equal to 0. So we get the relation b is equal to negative av. So let's keep this equation in our mind, and let's move to second equation, right? So Either remember this, let me write it, okay? Now let me erase this and let's move to second equation, right? Now suppose there is an event, let's name it as event 1, okay? Event 1, okay? Now it is in the starting when this is S frame. Let me take another stock to explain it. And this is S prime frame when both O and O prime are coinciding. Then at that moment there is a light source. There's a light source from which light is being emitted in all direction. Okay. Now after, so of course this is t is equal to 0 and it is equal to t prime also over here. Okay. Now for S frame, after some time the light will be over here. And what will be the distance for S frame? The distance will be CT, right? For S frame. And for S prime frame, the light will be over here. But over here the distance will be CT prime. Because it itself is moving at a velocity v. Right? Correct. And of course this is x-axis. We all know it. So now let's write over here x is equal to, x prime is equal to ax plus bt, correct? Ax plus bt, right? Now what is ax? Sorry, we don't have right now. So what is x? This is actually x, right? So x is equal to ct, act plus bt, correct? Okay. Now we know the relation that av plus b is equal to 0. Av plus b is equal to 0. So from here we can say that b is equal to negative av. Now just substitute this value. Let's see what we get. When you substitute this value, you get x prime is equal to act minus avt, correct? We get this relation. And now this is equal to ct prime, right? This is equal to ct prime with respect to S prime frame of reference. Okay? Because x prime is equal to ct prime when we have just now written it. Okay? So now just solve it. What you will get? You get AC. We can take AT as common. So we will have AT times C minus V is equal to CT prime. We have got one equation. Now let's solve for T prime over here. Let's see what we get. So for T prime, when you solve for T prime, what you get? T prime is equal to D into X. What is X? X is equal to CT. So we have dxt plus F times T. So we have this relation now. Now what to do? Well, we can substitute T prime over here and we can solve it. Once you substitute it over here, let's see what we get. AT times C minus V is equal to C, and we can take T as common. CT can be taken as common. Why I have written X over here? It will be C, sorry. DC plus F, right? DC plus F. So we get So t and t gets cancelled. So we get the final equation as AC minus AV is equal to DC square plus FC, right? So now let me write this equation over there. So we have this equation DC square plus FC. DC square plus FC is equal to AC minus AV. Okay. Now let's take because there are four variables. I mean A, B, and D, and F. So we need four different equations to solve it, right? So now we have to take another case. So let me erase this, then we'll see that. Now let's take event number 2. Okay. So in this, the light is moving in negative x direction. So this is S frame. What is the distance? Suppose it is CT only, right? And for S prime frame, it is CT prime, right? Okay, this is for S prime frame. Now what will be the calculation over here? X will be minus CT and X prime will be negative CT prime. Okay, now let's solve it. So X prime is equal to AX plus BT, right? Now X prime is equal to A. What is X? X is equal to negative CT. So we will have a negative sign over here. Negative ACT minus AVT. Correct? Minus AVT. Because B is equal to minus AV. Right? Okay. And what is X prime? X prime is equal to negative CT prime. It is equal to negative ATC plus V. So this will become positive. Right? So this is another equation. Now let's solve for T prime over here. T prime is equal to dx, that is negative C T D plus F times T. Correct? Now you can just you can take T first of all common. So we will have F minus DC. Now let's substitute it over here. So you will get C times C times what is T prime? It is T times F minus DC. F minus DC is equal to AT C plus V. So T and T gets cancelled. So we will have FC minus DC square is equal to AC plus AB. Right? We have this equation now. Fine? Okay. Now before going to the fourth equation, first of all let's add these two equations. Let's see what we get. So on adding these two equations, this and this, we will get 2FC is equal to 2AC is equal to 2AC is equal to AC. So 2 and 2 gets cancelled, C and C gets cancelled. So F is equal to A. So from here we have a relation F is equal to A. Okay. We have F is equal to A, right? And let's write this equation also. The equation is FC minus DC square. FC minus DC square is equal to AC plus AB, right? Now let me erase this and let's move to the fourth case. Sorry, not the fourth case, I meant event 3. Now in this case, this is S frame, and of course the light is spreading in all the directions, right? So it can go in Y direction also. This is equal to Y, right? Okay. And now for S prime frame, what will be the result? First of all, let me tell you one thing. X prime is equal to AX plus BT, correct? AX plus BT. Now over here, X is equal to 0. X is equal to 0. So what will be X prime? x prime will be dt. Now what is b? B is equal to minus avt, correct? So this is x prime coordinate over here. And now what is y? Y prime? Y prime is equal to y. This is what we had checked in the previous, I mean in Gaussian transformation we also use this. Why? Because there is no motion along y axis, right? So it means y prime is equal to ct, and of course z prime is equal to z is equal to 0 because there is no motion along z axis. Okay. Now we have to calculate the distance of that photon in s prime frame. So we will have d square is equal to x prime square plus y prime square plus z prime square. That's it. That's how you calculate. So what is x prime? It is equal to a v square t square, a square v square t square plus z square. Okay. Now what is d square? Just think once. D square with respect to this, what is the distance traveled by the light photon? It will be the speed times the distance, the speed times the time, distance in speed and time, right? So ct prime. So d is actually equal to ct prime square, I mean ct prime, right? So we will have is equal to avt square a square v square t square plus c square t square, right? And what is t prime? T prime is equal to dx. Now what's d? We don't know the value of d, but we know the value of x. X is simply 0 over here, right? So x is equal to, so we have ft, which is equal to at. A is the constant. We have proved f is equal to a, right? So from here we can clearly say it is c square times a square times t square, because t prime is equal to at. And this is equal to a square v square t square plus c square t square. Now t square will get cancelled both sides, so we will end up getting c square into a square, that is a square c square is equal to a square v square plus c square, right? Plus c square. Now what we can do? We can take this over here and we will get a square c square minus v square is equal to c square. So from here we get a is equal to plus minus 1 by square root 1 minus v square by c square. Now what is correct, plus or minus sign? Let's check it. So we have got a is equal to 1 by 1 minus v square by c square, right? Don't worry about the negative sign right now, I will tell you in a few moments. Okay, so a is equal to this and f is equal to a, so we have got the value of f also, and b is equal to negative av, so we have got the value of b also. And what is the value of what will the value of d? Well, from here you can solve it. We have fc minus dc square is equal to ac plus av, right? Okay, so clearly this is a, ac and ac gets cancelled, so d is negative av by c square. Okay, so we have got the value of d also, negative av by c square, right? So now let's substitute it over here. So x prime is equal to, what is a is this, and b is equal to negative av, so a x minus a vt, so it is equal to x minus vt by square root 1 minus v square by c square, and this is x prime, and of course y prime is equal to y, and z prime is equal to z, right? And t prime is equal to, let's solve for t prime also. So t prime is equal to d negative av by c square plus at, so you can take a as common, avx, so you can take a as common, t minus v by c square x. So you get t prime is equal to t minus v by c square x by square root 1 minus v square by c square. Now the original question, that why we have neglected negative value of a. Well, if a was negative, this value, then of course a you have taken common, so you would have got x prime is equal to vt minus x by square root 1 minus v square by c square. Okay. Now, when velocity is equal to 0, then it would imply x prime is equal to negative x, which is wrong. We know it. And when what should be the actual case, what should have been the actual case is that x prime should have been equal to x when they both are at rest, right? But when we assume a is negative, then in that case we get vt minus x instead of x minus vt, right? So that is the problem. So that is why a should be positive. Okay. So now let me tell you one more thing over here. If velocity is very less than c, then in that case you approach to Gaussian transformation. X prime is equal to x minus vt, y prime is equal to y, z prime is equal to z, and t prime is equal to t, when velocity is very small, right? So clearly this is a modified version of Gaussian transformation, right? Or Gaussian transformation is an approximation of Lorentz transformations. So now let me erase this. We have got the equation. Now what will be its inverse? That is, if we have to calculate, if you know the data for x prime, t prime, then how you will find x and t with respect to s prime frame? We will do it like this. X will be equal to x prime plus vt, because now what will happen? If s prime is making the observation, so with respect to this frame, if this is making observation, then s frame is moving in negative x direction with respect to s prime frame if it is making the observation. So it means that in this case velocity will be negative v. So we will have x minus v, that is plus vt by square root 1 minus v square by c square, and similarly y prime is equal to y, z prime is equal to z, and t is equal to, sorry, y is equal to y prime, and z is equal to z prime, and t is equal to t prime. V is again negative, so plus v by c square x prime 1 minus v square by c square. So this is the inverse Lorentz transformation equation, right? So now let me erase this and let's solve 1-2 problems to understand this, and they are very basic problems, so you don't get confused, okay? And you will find it everywhere actually, those problems. Okay, so let me erase this first of all. So question number 1 is prove the invariance of x square plus y square plus z square minus c square t square under Lorentz transformations. Okay, so it basically means that x square plus y square plus z square minus c square t square is equal to x prime square plus y prime square plus z prime square minus c square t prime square, right? So we have to prove this. So let's start with x prime square plus y prime square plus z prime square plus minus c square t prime square. Now clearly y prime is equal to y and z prime is equal to z, okay? So we don't need to worry about this expression because that is always true. The thing over here is that we have to solve for this c square t prime square. Now what is x prime? X prime we have calculated. X prime is equal to x minus vt by 1 minus v square by c square. And what is t prime? T prime is equal to t minus v by c square x by square root 1 minus v square by c square. Correct? Okay. Now what's x square? X square is basically equal to, we are squaring this term now, x square minus 2vxt, or if you get confused, 2x vt plus v square t square 1 minus v square by c square. Now what is c square times, now what is t prime square? T prime square is t square minus 2v minus 2 tv by c square x plus v square by c raised to power 4 x square by 1 minus v square by c square, and when you multiply by c square, let's see what you get. Minus c square t square c square t square c square t square minus 2tvx 2tvx plus v square by c square x square 1 minus v square by c square, right? Now just subtract these two terms, what you get? Of course this and this will get cancelled, and let's take x square and this term together, so you will have x square 1 minus v square by c square minus, you can take minus t square common, c square minus v square divided by, or you can take c square as common also, 1 minus v square by c square and 1 minus v square by c square, and once you take this common from the numerator, you will get x square minus c square t square, and of course plus y square plus z square. So it is true. So it means that this expression is invariant under Lorentz transformation, right? And in fact, if there are two events, this s and this s prime frame, suppose this there is an event 1, this is event 2 over here. So with respect to s frame, it is x1 y1 z1 t1, and it is with respect to s prime frame, it is x1 prime y2 y1 prime z1 prime and t1 prime. Okay, this event 1, and event 2 is suppose x2 y2 z2 and t2 with respect to s frame, and x2 prime y2 prime z2 prime and t2 prime for with respect to s prime frame. So you can prove it easily that delta x square plus delta y square plus delta z square minus c delta t square is also invariant. How? Let me erase this, or let me write it. You can prove it yourself, right? I've told this method, same you have to apply there. Okay, just we have two events now. So what is delta x? It is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square minus c times t2 minus t1 whole square is equal to x2 prime minus x1 prime whole square plus y2 prime minus y1 prime whole square plus z2 prime minus z1 prime whole square minus c times t2 prime minus t1 prime whole square, right? Okay, you can prove it yourself. Okay, so now let me erase this and let's take one more example and then we will end this lecture. Okay, now the expression which I had written before, delta x square plus delta y square plus delta z square minus c square times delta t whole square, it is called the interval between two events. Okay, now with respect to different frames, you put a prime sign and then you solve, right? What I have proved earlier, means which I had written. Okay, so it is called the interval between two events. Okay, so now let's take another example. Now let's be practical now. This is Earth, and suppose you launch a rocket with a velocity 0.6 times the speed of light. Of course, we can't be practical over here because this we haven't reached this velocity for our rocket till now, but still it makes sense. So this is S frame. S frame is what? Earth, the observer on Earth, and suppose it moves for some time. Of course, it is still moving at 0.6 c. Now, When 1 hour has passed in rocket, it emits a photon towards Earth. Of course, if it's a photon, it will be having speed of light as the velocity. Okay. So it means that t prime is equal to 1 hour. Okay. And x prime will be what? 0. Because for the observer in S frame, he is at rest, right? So it means that he is at rest. So it means x prime will be 0 because he is at the center now. Means he will consider himself as the center, right? That is, x prime will be 0. Now now with respect to Earth, after how much time the signal was released? Because with respect to this observer, after 1 hour from the uh, launch of the rocket, 1 hour was passed according to the person on or the observer in rocket. But with respect to person on Earth, what will the time at which the signal is released? So in this case, we will simply use t prime is equal to t prime plus v by c square x prime, right? Again, we know x prime is equal to 0. So t is equal to 1 hour divided by 1 minus v square by c square. V is equal to 0.6. When you square, you get 0.36. 0.36 c squared divided c squared will be square root of 1 minus 0.36, which is equal to 1 by 0.8, which is equal to 1.25 r. Correct? Okay. Now if you want to convert it in second, then also fine. If you don't want, then also it's fine. Now, okay. So after 1.25 hours, the signal is released from the rocket with respect to the person or the observer on Earth, right? And after how much time will it reach on Earth? Well, it is moving at the speed of light. Okay, so we know x is equal to x prime plus vt prime. While writing the inverse, if I had written vt over here, then please ignore that it is vt prime. Sorry, if I had written vt over there, square root 1 minus v square v square by c square, right? Okay. Now again, x prime is equal to 0, so we will have x is equal to, what is the velocity? 0.6 times the speed of light times 1 r divided by square root 1 minus v square by c square, right? And when you will solve it, you will get 0.6 divided by 0.8 times the speed of light times 1 r. So it is 0.75 ch. Now you can substitute the value, so you will get so you get 3 by 4, 3 into 10 raised to the power 8. Of course, the exact value is like 299,792,458 meter per second, the speed of light. But for approximation, we use 3 into 10 to the power 8 meter per second times 1 hour, that is 3600 seconds. So it is in meter. Okay. You can solve it. This will be 900. So it is equal to 3 into. So this is the distance, right? Now after how much time will it reach Earth? We simply know the formula. Time is equal to the distance, we know x, divided by the velocity, right? So what is x? X is equal to simply you can use this value because you have to divide by this quantity c. So c and c gets cancelled, 0.75 r. So the total time taken to reach on Earth is 1.25 plus 0.75, which is equal to 2 r after the launch of the rocket. Okay, so this is the answer. So this is a very nice problem which we use many a times. Currently we don't have such technologies, but if we will be able to make such rockets, then we will be using special theory of relativity a lot in that case. But yeah, for to make precise calculations, we must be well acquainted with general theory of relativity, because uh, there is something called as gravitational time dilation too, and other things which we have to take into account while making these calculations to make them more precise. Okay, so this is the end of this lecture. So I hope so that you enjoyed this video. If you did, then please do like, share, subscribe, and please support this video. Bye bye, take care.